So in this tutorial, we'll be using Amazon SageMaker Autopilot. So basically, this is a service that's provided by AWS where you can train, deploy, and create endpoints for your dataset. But your dataset should have features and the target variables. So the target values, they have to be labeled. So SageMaker basically what it does is we need to provide a raw data on S3 bucket. So S3, it's a storage, basically a data lake provided by Amazon, where you can store data, you can govern, you can perform various kinds of analytics, you can run SQL queries, you can create visualization. So it's really amazing storage. And so here I have several buckets, and so we will be creating a model for my data set that's called diabetes. It's basically it has, so let me actually open and just to see how it looks like. Let's see, I need Jupyter environment. I'll just open Jupyter environment. I have an account Jupyter environment that's installed on my computer. Well, currently I'm using Mac, but you can use Windows as well to perform all the functions, including this Anaconda environment. So let's download and see. So we can select and we can perform copy to S3 URI, copy URL. So you can access actually from a web browser as long as you have this URL. Okay, so we download it. I just want to take a look at it. Here we go. So this is our data set. So header, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, prediction function, age, and outcome. So basically those are my features, or in statistics those are independent variables, and my target variable is outcome, or dependent variable on statistics. So as you can see, those are all the numbers that are given, and our outcome is either 1 or 0. 1 means that person with these features probably likely to have a diabetes. 0, no. So basically we don't have a lot of data, around 769 rows, but by providing this data through SageMaker Autopilot, it should create us a machine learning model, and we can deploy it. And so once we have an endpoint, for example, we can provide any. So if we can, so for example, once the model is ready, all the artifacts are ready and deployed, and there is an endpoint, we can pass these parameters, and our model it gives an answer. Basically it makes prediction whether person has diabetes or not. So let's go back. Hopefully it's clear. So let's get started with Autopilot. Okay, so once we are here, we need to, so there is a studio, so we need to open SageMaker Studio. If you don't have one, you can create here as well. And then once you create, you need to also see what you can add users. So it's very advanced, and you can give an access to certain people who are going to work on this. So this is our environment. So basically here you can see the status of jobs and your files. What we are going to do is we're gonna do a new launcher, and here we have a new autopilot experiment. So basically for the configuration is that we need to provide the following information in order for this thing to work. It's super fast, and first of all we need to provide our raw data, which is that file that I showed you, tabular like CSV file. Then we need to let Autopilot know about our target variable. In our case, it's an outcome. And then this Autopilot, what it does is it applies automated ML techniques to analyze data. So on the background, it keeps track of all the data analysis with feature engineering, model training, and validation. So basically, whatever we do manually, this Autopilot, it does everything. And the very good thing is that it's not a black box model. So basically, it executes models. It executes models, and it tunes all the parameters. So basically, it does a lot of job for us. If I would do it myself, it's probably gonna take like months of work to do the whole thing. But here, with the help of like Autopilot, you can create in a matter of like 1-2 hours. So it is super advanced, but you have to know some things. So then once automated ML technique runs, and then it identifies the best model candidate. So it does it does run and try like many models, and it identifies the best model, then ranks them based on the accuracy that we provide, such as F1 score or accuracy, or there's AUC also. So let's dive in. Create a new experiment. We need to give a name. Let's give this experiment. And we don't need to give any keys, but however we need to show where our data set is. Our data set is saved on this, and this is the US East one. I'm located close to Washington DC, so I'm very close to this location, so that's why I chose US East. And dataset name, diabetes, target variable here. So as you probably know, you have to have headers on your dataset. So this is one must. So if you cruise down here, this is the outcome is our target variable. Others are our features. So let's choose outcome as a target variable. And so here we need to show our output location, where all the results, all the experiments will be saved, or all the artifacts. So we're gonna save on the same folder, in the same folder. And here also you need to show what type of machine learning problem we are trying to solve. So in our case is 1 and 0, right? So it's binary classification. However, your problem may be regression or multi-class classification. So we need to show, or you can just do auto, but it's gonna take a little longer. Still, like Autopilot is going to figure out your problem if you don't know. But in our case, we know that it's a binary classification. And as an accuracy, we can, as I told you, we can do F1 or accuracy or AUC. I'll just choose accuracy. And here we have an option to deploy. So let's not deploy for now. So let's create an experiment. So as this autopilot is doing, as this autopilot is doing an experiment, you can keep track of what the system is doing. Here, for example, so like it goes through all of those processes: pre-processing, candidate definition, the feature engineering or model tuning. Then it creates those 2 reports that are very detailed, and so it's, and as I said, it's not a black box. It's very detailed, and you know what the system is doing, and it records all the records basically. And the good thing is that once you have your final model, if you know with the knowledge domain and with your expertise, you can tune and you can even make that best model even better. So it gives you that ability, and you can of course deploy and make some predictions. Thank you. So let's check how our model is doing. Basically, so right now it's been 43 minutes, and right now we are at the model tuning phase where Autopilot tries various parameters and to see which parameter change will give higher accuracy rate. And I also want to talk about this jumpstart. So basically, this SageMaker Jumpstart, it gives an access to pre-built machine learning solutions and the pre-trained models from AWS. So basically, there is so many use cases for this Jumpstart. For example, if you work in the bank, you can use fraud detection pre-trained model. It tries to identify the fraud. Or you can do predictive maintenance if you have some car or some equipment, and it can predict when the maintenance has to be done, or just demand forecasting. Also, this includes pre-trained models such as NLP, natural language processing, or object detection, image classification. So this is really cool. So let's cruise up here and see what it offers. So here, as you can see, there is natural language processing models, solution for document understanding, document summarization, entity and relationship extraction from text, fraud detection, explain credit decisions. Even there is BERT, very popular BERT base that tries to that classifies and that tries to guess words. Basically, source it's TensorFlow. Vision models, image classification with object detection, image embedding. So it's really cool, but you still have to have domain knowledge in order to fully utilize it. And you need to tune and tweak, of course. Thank you. Okay, so our experiment is complete. Here we can see some performance, some reports from here. So basically, when it's complete, it gives you the status that it's complete, and you can review some explainability reports, performance of it. And also artifacts. Artifacts are saved here on our S3 bucket. Later we'll show. Also, based on the experiment, it says that XGB Boost is the best algorithm, and we can deploy it right from here. And once we deploy it, it's gonna give us that ready to use endpoint, and then we can invoke some numbers, and it's gonna predict for us. So let's review more in details. So those are the models. See, those are the trials that what Amazon SageMaker Autopilot has done for us. So it has run like hundreds of models, and did tuning as well, and it generated those two notebooks. One is exploration notebook, so data exploration, where it gives you all the insights of the data that we need, including descriptive statistics that we need for our initial analysis. So as you can see, this is the dataset properties. It has 768 rows. All of them are numeric. There is no categorical, no text, no date, or no sequence has been identified. Yeah, and that's correct. We know that there is no categorical and we know that there is no categorical values. This is our target analysis. 65% represents 0 and 1, and remaining is 1. So this is just the data sample. This is our outcome and all the features. And see, even Autopilot, it tries to identify whether if there is duplicate rows, and it says that no duplicates were found, which is great. And here creates for us the correlation with matrix. And here's our correlation matrix for our features. And as you can see, as it goes, we can see that these dark blues are highly correlated. For example, age in pregnancy, it has 54% correlation. There's 44 insulin, and the skin thickness, which makes sense because as skin thickness may mean that there's problem with insulin, and the BMI is also important. So see, BMI and skin thickness has a high correlation. But higher BMI means higher skin thickness. So we can perform some kinds of analysis here, and when we're doing so further, you can modify and work with features if there is multicollinearity among features. You may want to remove some of the features, so you can increase the accuracy of your model. And here it also works with missing values. It tries to identify missing values in our dataset and says that it did not identify. Also looks for categorical values, and it says we found 0 in 9 of the columns would contain missing values. Also it looks at cardinality. So see how advanced that is. It even looks at the cardinality of those categorical values. and this with unique entries and unique entries in each feature. So outcome has 2, we know that, and then the remaining we can see that here. And here are some descriptive statistics which you can look at: the mean, median, mean max values, outliers. So it's very detailed, so it documents everything. And the second notebook that has been generated, it is Autopilot with candidate definition. So basically, this is where this is the report. This is the report where Autopilot identified the best model, and also it explains how what it did in order to identify. So for example, DPP0 XGB boost, it ran this XGB boost algorithm and checked for numeric features using a robust imputer. Also, standard scaler has it tried to convert those categorical values using standard scaler, but in our case we did not have any categorical values. And this is the second algorithm, third, fourth, and so on. So it ran all of those models in order to identify the best one. And this is all saved. This is all saved in S3 bucket. So here it even labels us that it's the best model. Okay, so now we can deploy this model. So let's try to deploy it. Let's give it a name. Instance 1. And deploy. So now, it's ready. So basically, now you can. So this is the endpoint in JSON. So you can. There's a. Let's go to Amazon SageMaker. And here you can see all the notebooks, processing jobs. And as you can see, those are the models that and this is the experiment that we did. So those are the those are the jobs that Autopilot performed. Training, algorithms, training jobs. So those are all the work that has been done by Autopilot. As you can see, this is a lot of work, and Amazon Autopilot did for us in a matter of 2 hours. And here we can see our models and endpoints. Model and endpoint. And this is our endpoint that's ready to predict any if we pass any data in the format of like JSON or so developers know it, and it predicts for us. This is ready model. And of course, with an additional and of course you can improve model with the domain knowledge by tweaking some parameters. And let's take a look at S3 data lake. I think we saved here. Here, diabetes experiment. And this is all the documentation. So basically, I'll just explain you overall what information can be found where. So this this documentation basically it has an explainability report that gives you the details of feature with greatest attribution. So let's take a look at it. Documentation, explainability, and also you can find analysis, I think, here. Yeah, analysis here. And here, feature with a greatest attribution report, I think, that you can see in PDF. So as you can see, most attributing factor for our outcome, in predicting the target variable, and so glucose is highest attributor. Of course, like if you have a higher glucose, that means you have a problem with the diabetes. BMI, second factor is BMI, third factor is age, then blood pressure and insulin. These are not significant factors. And preprocessed data, you can find your samples, your header, your training, your validation set, your training set, your validation set, also some tuning work that has been done for the training set and validation. So as you can see, it saved all the work that was done in tuning phase. So this is it, and I already showed you. So the most important thing from here is that we identified our best model, and it gave us whole code, and we can with that trained model we have the artifacts of the model, and so we can use that trained model everywhere, even like outside of AWS, and you can modify the notebook, and you can improve your model, of course. Thank you very much, and
If you have any questions, just feel free to submit your information, and I'll get back to you on the contact page. Thank you.